Good day, everyone. For today's presentation, we're going to talk about binary search and bubble sort. Here's the list of our members. Before we get right into the presentation, here's the list of the content we're covering today. And there will be an introduction to searching and sorting, and then we'll talk about bubble sort and binary search. And to begin with, what is sorting and searching? Sorting, just like the name suggests, algorithm will put elements into an ordered list, and whether it is ascending or descending order. Types of sorting include bubble sort, selection sort, insertion sort, merge sort, and quick sort. In searching, it will check for an element that is included in a sorted list, and the searching methods include linear search, binary search, hash search, and tree search. And next, we're going to talk about bubble sort. It is the simplest sorting algorithm, and how it works is by comparing one element in the list to another element next in the line of an unordered list. And it will swap places if it's necessary and move on with the list until the end, which can be both in ascending or descending order. And this is an example of a bubble sort in ascending order.
It will need a function which include nested loop to implement bubble sorting. It will repeatedly sort the adjacent element if they are in the wrong order. It will make n-1 passes through a sequence of n elements. Each pass moves through the array from left to right, comparing adjacent elements and swapping each pair that is out of order. In the first pass, compare the first two elements 7 and 6, and then have to swap them because 7 is greater than 6. And compare the next two elements 7 and 4, have to swap them again because 7 is greater than 4. And then the last two elements 7 and 3, have to swap them again because 7 is still greater than 3. And the pattern will continue until all the elements are sorted in ascending order. In this algorithm, the big O is O n to the power 2. Its efficiency will decrease as the size of the data increase. This sorting is slower than other sorting algorithms, so it is not suitable for sorting of large set of data. These are real-world problems in sorting, like sorting names in alphabetical order, sorting people according to their height, organizing a playlist, contact list, etc. This is the example for bubble sort. It will take 4 passes to complete the sorting.
We downloaded a program for bubble sorting of downloaded files. The class diagram consists of 3 classes. To perform bubble sort on an array, we use a nested loop structure. The outer loop goes from the first element to the second to last element of the array. During the inner loops, we compare the size of the current element with that of the next element. If the current element is larger than the next element, they switch positions. This comparison and sweeping process continues until the elements have been compared, resulting in a fully sorted array. Finally, the function returns the sorted array. These are the source code. The download file class represents a downloadable file. In the bubble sort class, we implement the bubble sorting function that performs the bubble sort algorithm on the array of download file object. This is the output of the code. The main bubble sort class contains the main method, which creates an array of the download file object, calls the bubble sorting method from the bubble sort class to the sort array, and then print out the sorted array to the console.
So now it's time for the binary search. Binary search is an efficient algorithm for finding an item from a sorted list of items by dividing the list in half until it's reduced to a single location. And it is one of the most common way to find an item in an array. The time complexity of binary search is O log n. Next, as you can see here, we provide an example for how binary search works. In the example, there is an array for there's an array and the data that we have to search. The important thing in the binary search is that the array has to be sorted and it has to be in ascending order. As you can see here, the array is already sorted and the array size is 15. So the total index will be 14 as the array index starts with 0. Then first of all, we have to mark the first index 0 as the low and the last index as the high. Moving on, we have to find the mid from that. To find the mid, we have to do addition the first and the last index, which are 0 and 14. Then we have to divide it with the numbers 2. In that step, we have to consider that there can be 3 conditions. The first one is the data that we want to find can be higher than the mid. Then we have to move the low to the right side after the mid. The second condition is the data that we want to find can be lower than the mid. In that case, we have to move the high to the left side, which is before the mid. And the last condition is the data and the mid could be the same. In that condition, we can say that we found the data in the array and the searching process will be stopped. So let's go back to this example. As in the first step, we have to find the mid. So after the addition and division, we got the mid, which is 7, where the element is 35. Then we have to compare the data and the mid element. But as you can see here, the data is lower than the mid. So we have to move the high to the left side before the mid. Now the conditions are changed. The low is still at the index 0, but the high is now at the index 6, where the element is 32. Then we do the process for finding the mid again. During the addition, the index 0 and the index 6, we will get the element which is 14. After that, we compare the data and the mid. So now the data that we want to find, which is 14 and the mid are same. Therefore, we found the data in the array and can set the searching process is done. And for the next slide, we provide the real world problem for the binary search. Well, it can be find system, game development, browsing the web, directory, and the stock market.
We have developed a program to search for a student name in the baking class using binary search algorithm. Here are the class diagrams for our program. To perform the binary search, we set the first index low and the last index high as 0 and let -1 respectively. Then while low is equal or less than high, we have to find the middle element and then check the element to be searched is present at the middle. If the element present in the middle, return the value. If the searching element is greater, ignore the left. If the searching element is lower, ignore the right half. And then return the value if the element is found, or else return null. These are the source code for our binary search. We created the student name array by using the object variable student, and then store our student name in this array. Inside the baking class, binary search methods will search the data and return its value. This is the main class. Inside the main class, we already store the names according to the alphabetical order because binary search will work properly only if the dataset was sorted first. We will search for a student, and if if the student is present, and then return the name, and here is the output. This is the end of our presentation. Thank you for your time and attention.